All right, everybody. So number 7, it says the cross section below, the cross section of Earth below represents a P wave moving away from an earthquake epicenter. Seismic station A is shown on Earth's surface, right? So just a reminder, when an earthquake occurs, the epicenter is the origin, right? Where the earthquake happens. Once an earthquake occurs, it sends out a P wave and then an S wave. So the P wave arrives first and then the S wave. It says at station A, the first P wave arrives 11 minutes, 40 seconds after the earthquake. How long after the first P wave, sorry, how long after the first P wave arrives will the first S wave arrive? All right, so we need to go to page 11 of the reference tables and remember this number, 11 and 40 minutes, right? The P wave travels 11 minutes and 40 seconds. So therefore, I'm gonna just zoom, and 11 minutes and 40 seconds is right here, right? This point right here. All right. So now I'm going to draw my line. All right. And I'm going to draw 11 because each box goes up by 20 seconds. So I'm going to draw my line until I hit, I know it's not straight, but right here. It hits my P wave here. And I need to know how many more minutes will then the S wave arrive. So now what I'm going to do is I'm going to track where it hits, right? Because now we know the distance to the epicenter. I'm going to follow it to the S wave right here. And now, go here. Here we go. All right. 21 minutes and 20 seconds. So when I zoom out, when the P wave arrives at 11 minutes and 40 seconds, the S wave arrives at 21 minutes and 20 seconds. So the difference has to be between the two, all right? The difference has to be between the two to find out how many minutes after the P wave will the S wave arrive. So when I subtract, I'm going to subtract right here, 21 minutes. Let me bold it a little bit more. 11 minutes and 40 seconds. All right. And when I subtract, I can't do 20 minus 40, so I need to borrow a minute and add 60 seconds. So 80 minus 40 is 40. 20 minus 11 is 9. And so now that time lets me know that is 9 minutes and 40 seconds after the P wave have arrived, which is choice number 3. Number 8, the Aleutian Islands extend westward from southern Alaska to form the northern boundary of the Pacific Ocean. These volcanic islands were formed by the nearby blank. All right. Well, we know volcanic islands, they actually come from a convergent plate boundary, right? Volcanic islands are formed, right, from a convergent plate boundary. So we can definitely remove choice 3 and 4, all right? Now we need to know, is it the subduction of a continental plate or a subduction of an oceanic plate? Well, let's see if we can find these Aleutian Islands that extend westward from southern Alaska to form the northern boundary of the Pacific Ocean. Let's see if we can find it on page 5. All right. So Alaska is located right here, right? So the southern part of Alaska is in this area, and you see these gray dots represent the Aleutian Islands, which means that we are dealing with right here, the Aleutian Trench, right? Now, this white, right? The white part of this map represents water. And so therefore, the subduction of this, of this crust, this white part represents water, right? The ocean floor. And so therefore, this is the subduction of an oceanic plate, which is going to be choice 2. And we always know, just in general, when an oceanic plate is coming into contact with a continental plate during a convergent plate boundary, the oceanic plate is more dense. So it's going to subduct or sink under, right? And for every convergent plate boundary, right, you'll see on page 5 is also labeled subduction zone. All right. Number 9. So it says a cross section below represents a pattern of magnetic field reversals preserved in the igneous bedrock of the oceanic crust east of the mid-Atlantic ridge. Which cross section best represents the magnetic field pattern west of the mid-Atlantic ridge? All right. So if we take a look, let's take a look at fact 27CI2A. 27CI2A. All right. It says right here, the evidence of seafloor spreading is a pattern of magnetic polarity, is a mirror image on either side of the ridge. And you look at this as an example. The ridge is in the center, and you'll notice, right, it's completely symmetrical from the center heading to either to the left or to the right. It's a mirror image. So now that I know that, all right, from the 0 point to the right, I should see the same image from the 0 point to the left. So if I see a long gray box here, then there should be a long gray box here. The second thing I see to the right is a short white box, then therefore there should be a short white box here. If I see a short gray box, then there should be a short gray box here. If I see a long white box as my fourth thing from the right, then I should see a long white box as my fourth thing from the left. And if I see a long gray right before I hit 40, then I should see a long gray right before I hit 40. All right. So I'm looking to see which of these represent the pattern. Remember, we start off with the long gray, so it definitely can't be 204. And if you look where 40 is just before 40, there is a long gray box here that shows right here. So when I'm matching, the best one that shows that is choice 1. When the seafloor moves, number 10, when the seafloor moves as a result of an underwater earthquake and a large tsunami develops, what will most likely occur? Well, if I looked at fact 28B on my packet, fact 28B, it says tsunamis are giant waves caused by undersea earthquakes which cause severe destruction to coastal areas. So the best option for that, severe destruction in coastal areas, choice 4. Number 11, the block diagram shows below, which shows a tectonic plate boundary. Which tectonic plate boundary is best represented by this diagram? Well, we see right here the oceanic crust is sinking underneath the continental crust. We also see a trench, right, that was formed here. And so therefore, automatically, that just lets me know that this is going to be a convergent plate boundary. All right. So now I have to look at all 4 of these, right, and see which one is which one is the both plates are split up by a convergent plate boundary. All right. So therefore, when I check all four on page 5, this is number 11. When you go to page 5, all right, I'm gonna look at the one to Fuka, sorry. Let me take a look. Hold on. A North American plate boundary. So I'm gonna go to page 5. Here we go. And out of all four of those choices, the one where I see the convergent plate boundary is right here between Juan de Fuca plate and the North American plate. And remember down here, the symbols tell you what is a convergent plate boundary. And so because out of all four of those options, we see this one as the correct answer, which is going to be choice 3. All right, number 12. Number 12 says a cross-sectional view of Earth below, which shows seismic waves traveling from the focus of an earthquake. Points A and B are locations on Earth's surface. Which statement best explains why only one type of seismic wave was recorded at location B? Was recorded at location B. All right, only one type of wave received here. So if we look on fact, let's go to 28. Let's go to 28C and two I's, 28C, right? I2 and number 1. It says some areas on Earth's surface only receive P waves because S waves cannot travel through the liquid core. So the S wave cannot travel through the liquid core. That's why for number 12, the correct answer is going to be 1. Only one type of wave was recorded because the S wave cannot travel through the liquid core. Basic answers to question 13 and 14 on the passage below. Crustal activity at mid-ocean ridges. All right. So when you're reading, and well, question 13 says, which type of plate boundary is located at mid-ocean ridges? Well, one of the things that they mention, these ridges consist of extensive underwater mountain ranges split by rift valleys. The rift valley marks places where two crustal plates are pulling apart, right? So where two crustal plates are pulling each other apart, that's going to deal with, let's look at page 5 of the reference tables. And right here, arrows, right, that represent pulling apart. And it also lets you know, right, that mid-ocean ridges are created here. Every time that you see the word ridge, you're also going to see a divergent plate boundary. Every time you see the word ridge, you see the symbol of a divergent plate boundary. That's why the correct answer is going to be choice 3. All right, number 14, which mantle hotspot is located closest to a mid-ocean ridge? All right, so I'm gonna look at these 4 hotspots and I'm gonna see which one is closest to a mid-ocean ridge, right? Which means that I need to see which one is closest to a divergent plate boundary. So when I'm looking, all right, and I'm looking, so this is the symbol for hotspot. And out of the 4 hotspots that they give me, Canary Islands, Easter Island, Hawaii, and Tasman, I'm gonna look Canary Islands. So let's go take a look. Canary Islands is here. Easter Island hotspot is here. Hawaii hotspot is here. And the last one was Tasman hotspot. Oops. Tasman hotspot, which is right here. Out of all four that I circled, the one that is closest or literally on a mid-ocean ridge is the Eastern Island hotspot. You see how the symbol is literally on the divergent plate boundary, right? So that's why the correct answer is going to be choice 2. All right, so 15 says the map below shows a part of Earth's surface. Point A through D are locations on the ocean floor. At which location is the temperature of the ocean floor bedrock most likely highest? All right, well, let's look at fact 27C I1. So 27C I1, oops. It says right here, new crust continues to form at mid-ocean ridges when magma rising from the ridge solidifies. So it has to be the warmest spot or the hottest spot has to be where is magma rising from. And it tells us magma is rising from the ridge. So I just have to identify where the ridge is. So the ridge is this area right here that I'm highlighting in blue, where the symbol is, right? That's where the ridge is, where magma is rising from. And that's why the temperature would be hottest at sea. Exactly the point where hot magma is rising from, which would be choice 3. 16, the map below shows the Atlantic Ocean divided into zones A, B, C, and D. The mid-Atlantic ridge is located between zones B and C. So this dark gray area is the mid-Atlantic ridge. Which graph best represents the geologic age of the surface bedrock on the ocean bottom? This is for number 16. All right. Well, let's look at fact 27C I2B. 27, right? 27C. So 27C, let me erase this. I2B. All right. And look what it says. The age of the ocean crust increases as you move away from the mid-ocean ridge. So the age of the ocean crust increases as you move away from the mid-ocean ridge. So as I move away from this ridge, the age of the ocean floor should increase. That means I have to pick a graph that shows A and D are going to be the oldest, right? And B and C are going to be younger. All right? Because as you move away from the ridge, the ocean floor gets older. And that's why the correct answer is going to be choice 4, right? The mid-Atlantic ridge is where it gets the youngest. Is as you move away on both sides, as you move away on both sides, the age of the ocean floor increases. All right, it says, base your answers to questions 17 and 18 on the map below and on your knowledge of earth science. The map shows the coast of the northwestern United States. So they're giving us an idea where it is, right? The Explorer and Gorda ridges are part of the Juan de Fuca tectonic system. All right. The arrow on which map best shows the direction of movement of the Juan de Fuca plate in relation to the Juan de Fuca ridge. All right, in relation to the Juan de Fuca ridge. So what's that mean? So which of these arrows show the correct arrow of what the Juan de Fuca plate is doing? So I'm gonna look on page 5. All right, I'm gonna look on page 5. I'm gonna find the Juan de Fuca plate. All right. And when I zoom in, right, Juan de Fuca plate right here, right, and this is northwestern Juan de Fuca plate. This boundary is right here because the map says the Juan de Fuca plate is right here, right? And this part, they told you, is the northwestern United States. So this gray part is North America. This is part of North America. All right, because it says Northwestern United States and the Juan de Fuca plate. So when I look on page 5, I see a convergent plate boundary. What does a convergent plate boundary mean? Let's scroll. It means that the plates are coming together, right? They're coming together in the same direction. So for that to be true, the North American plate is moving towards the Juan de Fuca plate, and the Juan de Fuca plate is moving to the right because this is a convergent plate boundary. So when I go, the one that shows the Juan de Fuca plate moving to the right is choice 1 because it represents a convergent plate boundary. All right, number 18. Number 18 says the Explorer Ridge is the boundary between the Explorer Plate and the blank. Let's take a look at the Explorer Ridge, right? So the Explorer Ridge is going to be outside right here, right? Explorer Ridge, the Explorer Ridge is the boundary between the Explorer Plate and what? All right. So once again, remember Juan de Fuca is here, right? Juan de Fuca is played here, and I see the Pacific Ocean is to the left of it. So we need to know what is this plate right here. Remember, we are Northwest United States. So when I go to page 5, I'm going to find this area where all these things are going on, right? And one thing I notice, I see the same ridge right here. The same ridge is right here. And so they want to know what plate is here. What plate is here? Juan de Fuca plate is where the dot is. What plate is here? When we zoom out to find this white part of the plate, what does it represent? And look, that whole area right here is all part of the Pacific plate. That's why the correct answer is choice 2. Basic answers to question 19 to 22 on the map below on your knowledge of Earth science. The map shows the major islands of the Galapagos Island chain. These islands were formed by volcanic eruptions as the tectonic plate passed over the Galapagos hotspot. The age of the volcanic bedrock on certain islands is shown in millions of years. Based on the age of this bedrock of the Galapagos Islands, in which direction does the tectonic plate containing the islands appear to be moving away from the Galapagos hotspot? And so it says, based on the age of the bedrock of the Galapagos Island. So one thing that I'm seeing a pattern of, right? This represents millions of years old, right? MY. And so I see that the age is getting older as I head in what direction? What direction is this generally? It's pointing down and to the right. And if it's pointing down and to the right, that direction is southeast. Number 20, it says the Galapagos hotspot is located closest to what type of plate boundary? All right. Well, I'm going to find the Galapagos hotspot on page 5 of the reference tables. All right. So let me refresh this. And let me find the Galapagos hotspot. All right. And so the Galapagos hotspot is located right here. And what symbol, because the question asks for what type, right? Not the name, just what type. These symbols right here where these lines are, right? You see these double lines? That symbol is the same double lines as what type of plate boundary? Right here. So your answer for 20 is what type of plate boundary is it? Divergent plate boundary. That is the answer for number 20, divergent plate boundary. 21, describe what caused a vesicular texture in some of the volcanic rocks that formed when lava cooled on these islands. All right. So one thing we have to remember, all right, volcanic rocks are for the most part igneous rocks, right? Volcanic rocks that formed when lava cooled, right? When lava or magma cooled, this is describing solidification, which happens only with igneous rocks. So they're saying what caused a vesicular texture in some of the volcanic rocks that formed when lava cooled. So I'm going to go to page 6 of the reference table, and there should be something there that tells me why. All right. So I see vesicular texture right here. And what type of rock is it? It is an extrusive igneous rock. Why is that important? Why is that important? Because you see the first two letters, right? X, that usually represents, right? Eggs, right? Exit, right? Outside, right? And so that means that these type of rocks were created on the surface. So these type of rocks, right? Let's say this is a volcano, right? And lava spewed out and it's flowing on the ground, right? And now lava is on the ground. When lava cooled here, it formed extrusive igneous rocks. Now, what do I know about extrusive rocks? So rocks that are extrusive means they cooled rapidly, right? They cooled rapidly, which means they cooled at a very fast pace. So the reason why those rocks have a vesicular texture is because they cooled rapidly. Extrusive rocks cool rapidly. Intrusive rocks cool slowly, which allows it to give it large crystals. But rocks that are cooled rapidly, they have little to no crystals and have vesicular texture, which means it has gas pockets on them. Number 22. It says some of the magma at the Galapagos hotspot is believed to originate 1,000 kilometers below Earth's surface. What is the approximate temperature, keyword we're looking for temperature, of Earth's interior at that depth? So we're looking for what is the Earth's interior temperature, right, at this depth of 1,000 kilometers. What page am I looking at? I'm gonna look at page 10 of the reference tables, right? And I'm gonna go to where my depth is 1,000, right? 1,000 kilometers, which means it has to be on this line. And when you take a look, when I hit the black line, right, that says interior temperature, right? The black bold line is interior temperature. I'm gonna look to the left, and I'm going to see that it is a little above 3,000. So it's not hitting the 3,000 line. It's a little above 3,000, which means my temperature would be 3,100 degrees Celsius. And that would be my correct answer. Basic answer the question 23 to 25 on the information and map below. An earthquake occurred in the southwestern part of the United States. Mercalli state intensities were plotted for select locations on a map as shown below. As the numerical value of Mercalli ratings increases, the damaging effects of the earthquake waves also increases. All right, that's something to keep in mind, okay? As that number range increases, the damaging effects of the earthquake waves also increase. So 23 says, using an interval of 2 Mercalli units and starting with an isoline representing 2 Mercalli units, Draw an accurate isoline map of earthquake intensity. All right. So they want me to draw an isoline starting with 2 Mercalli units. So remember, isolines are either going to be closed loops, right? Or they extend at the end of the map. So I see 2 right here. And I'm going to make sure that it connects to the dots. And that's my 2, right? And I got to extend the line. Now, keep in mind what the question says, using an interval of 2 Mercalli units. So that means I have to continue drawing lines every 2 Mercalli units. So the next isoline I'm going to draw is 4. So I'm making sure my line touches all the 4 and extend at the end of the map, right? And I extend at the end of the map. I don't want to go in this direction because that's where 5 is. And then 6, all right? And my 6 should cut off, right? And remember, because I see a 6 here, it's going to end up being a closed loop. All right, not extending towards the mat, a closed loop. So that means the numbers inside 6 will be greater than 6, and the numbers outside 6 will be less than 6. All right, so that's something to keep in mind. And this is what your diagram is. All right, make sure that you connect your dots right with all 4s that we see here. Extend it to the edge of the map. So it either has to, their lines have to either extend to the edge of the map or be a closed loop. If you can't draw a closed loop with a number without crossing the other numbers, then in that case, just extend it to the edge of the map. Number 24. It says, state the name of the city that is closest to the earthquake's epicenter. All right. So the earthquake's epicenter is going to be is going to be where the strongest, right? Where the most damage has occurred. As a matter of fact, if we look at fact 27C, 3 eyes, 27C and 3 eyes. All right. We also know that the epicenter would also be on a fault. So there's 2 ways that you could have found this. All right. I'm going to show you this the best way. The best way to find this is I see, since the damage is more intense, right, where I see 7, that means that the city right here, Pasadena, is going to be your answer, right? And the box represents a city where the damage is highest. So Pasadena is going to be correct. All right. And number 25, it says identify. Oh, sorry. I made a slight mistake for number 24 real quick. Let's go back to number 24 real quick. It wasn't 27C, I apologize. It was 28C. 28C, 1I. 28C, where is it? 28C and 1I. And it says right here, analysis of seismic waves allow the determination of the location of earthquake's epicenter and the measurement of earthquake's magnitude. All right, so basically it was just emphasizing where there's more tracking pretty much seismic waves will give us an idea of where the epicenter's earthquake is. All right, so that's the one thing I wanted to clarify. 25, right? Identify the most likely cause of earthquakes that occur in the areas shown on the map. That one will look on 27C, 3 eyes, which is right. Oh, did I pass it? 27C, 3 eyes. Did I pass it? There we go. All right. So it says right here, right? In a transform plate boundary, one plate slides past another. And all we see here are faults, right? That we see in a transform plate boundary. And because of that, they cause shallow earthquakes. So they should cause earthquakes. So your correct answer, the most likely cause of earthquakes that occur in the area shown in the map, faulting. If you were to also say, well, this area is also located on a transform plate boundary, that would be fine too. All right, that is all for this packet. Have a wonderful, blessed day, and I'll see you next time.